Hi, I am Angelo Mark P. Walag, and I'm honored to present our paper entitled A Canonical Correlation Analysis of Filipino Science Teachers' Scientific Literacy and Science Teaching Efficacy on behalf of my co-authors. The presentation would follow this sequence. I'd like to begin with a brief background, then the methods, salient findings, conclusions and implications, and of course the references and some acknowledgement. In the last few decades, educators have emphasized developing scientific literacy in science education programs. More so, the standard rationale for studying science subjects in school is the achievement of scientific literacy. To prepare students to do well in science, the science teacher is often considered to be one of the most influential factors in increasing the quality of students' total science learning outcomes. To effectively produce scientifically literate citizenry, we must first understand how to prepare our pre-service teachers and further develop our in-service teachers for science teaching. This is so since the success of science education reforms is contingent on the development of science teachers' self-efficacy. Scientific literacy is often regarded as the knowledge and understanding of the fundamental scientific ideas and processes necessary for the personal decision-making. Teachers play an essential role in developing learners' scientific literacy across all levels of education. A teacher's self-efficacy, on the other hand, plays a massive role in determining teaching practices, which includes selecting appropriate learning activities, organizing lessons, and preparing oneself in challenging and difficult situations. As noted by Bandura, self-efficacy construct is situation-specific. This indicates that teachers may feel very competent in teaching a certain subject while feeling less competent to teach another subject. This is because each subject has its own epistemological basis that require different teaching strategies, methods, and skills. The teacher's self-efficacy beliefs have been consistently found to be correlated between teacher classroom behavior and student achievement. More so, a moderate self-efficacy level was also correlated with teachers' scientific literacy. Pre-service teachers who possess fewer alternative conceptions had higher efficacy levels. However, Morrell and Carroll claim that science content knowledge is insufficient to improve teacher self-efficacy. This highlights the existing debate on how scientific literacy is correlated with self-efficacy. Thus, this study builds on the correlation between the teacher's scientific literacy and self-efficacy by utilizing a method not previously used in the literature, canonical analysis, in an attempt to bring clarity to this important teacher curriculum relevant question. As such, this paper seeks to address the following research questions. What are the science teacher's levels of scientific literacy, science teaching efficacy, and subject-specific self-efficacy? How well do science teachers' scientific literacy levels predict their science teaching efficacy and subject-specific self-efficacy? Based on the ongoing debates on scientific literacy and self-efficacy, this study hypothesizes that scientific literacy and science teaching self-efficacy are correlated, as shown in Figure 1. This present study also utilizes an explanatory correlational research design to unravel the relationship between two sets of variables. An explanatory correlational research design seeks to determine to what extent the two or more variables co-vary. The study involved 180 primary and secondary science teachers selected from all government-run schools while attending several seminars and workshops organized by the Department of Education in Cagayan de Oro City. The demographics are summarized in Table 1. Standardized instruments were utilized in the study as shown in this slide. A canonical correlation analysis was done to form two linear combinations, one of the predictor variables and one of the criteria variables, weighted differentially to attain the maximum correlation between these variables. Assumptions for the canonical correlation analysis were determined as suggested by different literatures. The multicollinearity assumption was determined using the Pearson's product moment correlation as shown in Figure 2, and none exceeded the 0.80 threshold. As shown in Table 2, majority of the respondents correctly answered all dimensions of the TBSL. The dimension where the most number of participants got correct answers are in earth science, health science, and life science. This implies that science teachers have a moderate level of literacy in terms of these subjects. The dimension where most science teachers got incorrect responses is in physical science. Overall, the science teachers possess satisfactory scientific literacy levels in all dimensions as it exceeded 62%, the passing score set by Losch and Spargo. As shown in this table, science teachers possess a satisfactory level of self-efficacy in all dimensions. This acceptable level of PSTE indicates that teachers are more likely to exert great effort to accomplish their teaching objectives and have persistence in facing different teaching obstacles. These same teachers also believe that their confidence in effective teaching could result in positive learning outcome. A canonical correlation was performed to investigate the relationship between science teachers' scientific literacy and science teaching self-efficacy. Table 4 shows the test for dimensionality for the canonical correlation analysis, indicating that 2 of the 6 canonical dimensions are statistically significant at the 0.05 level. Dimension 1, a canonical correlation of 0.045 with a lambda of 0.637 between the sets of variables, while dimension 2, the canonical correlation, was at 0.32 with a lambda equals 0.80. Figure 3 graphically shows the canonical loadings of the different variables of scientific literacy and science teaching self-efficacy. The inner circle represents the cutoff correlation of 0.3. Those variables that exceed the 0.3 signifies that these variables are correlated to the canonical covariate. As shown in Figure 3a, the canonical covariate was positively correlated with the content knowledge in science, technology, society, health science, earth science, life science, and the subject-specific self-efficacy in biology, physics, and chemistry. The first pair of canonical covariate demonstrated that a science teacher with a satisfactory science content knowledge in STS, health science, earth science, life science, and the nature of science held a positive self-efficacy in teaching physics, chemistry, and biology. The second pair of canonical covariate was found to be positively correlated with STS and negatively correlated with NOS and LS. The second pair of canonical variate demonstrated that science teachers who possess satisfactory literacy in NOS and LS were likely to be less literate in STS. Figures 3b and 3c, on the other hand, demonstrates a standardized canonical coefficients for the first 2 significant canonical dimensions for scientific literacy and self-efficacy. In this study, the correlation between science teachers' level of scientific literacy and science teaching efficacy was analyzed using canonical correlation. A positive and moderate relationship exists between scientific literacy and science teaching efficacy. The main components of scientific literacy that influences science teaching efficacy are their content knowledge in STS, earth science, life science, and health science. These findings suggest that science teaching efficacy is not only situation-specific, but also subject-specific. Science teachers possess high self-efficacy when teaching science subjects they are knowledgeable in. This study also confirms the long-standing notion that scientific literacy influences science teaching efficacy in specific subjects, while no significant correlation was found in the personal science teaching efficacy nor science teaching outcome expectancy. The study had some limitations, but the results still provide meaningful and practical implications for teacher education curriculum and teacher professional development. In terms of the design of the teacher education curriculum, an emphasis on the development of high levels of science content knowledge and STS is desirable to develop science teachers' science teaching efficacy, since self-efficacy beliefs are shaped early. In terms of in-service teachers' professional development, attention may be given to further improving their scientific literacy to effect quality science teaching. This work was supported by the University of Science and Technology of Southern Philippines under the research grant ROIRP 2018-33. And these are the references used in the study. Thank you very much, and I'm now ready for your questions.